What is the period of sine 2 theta? So previously we learned the periods of all sine theta, cos theta and all the functions. So let's review them. Sine theta, the period of sine theta is 2 pi, right? Cos theta is 2 pi, tan theta, cot theta is pi, cosecant, secant is 2 pi. So sine 2 theta, let's plot sine 2 theta. If you plot sine 2 theta, it goes something like this. It's similar to sine theta, but the frequency is very high. So this would be 0, this would be pi by 2, this would be pi, this would be 3 pi by 2, this would be 2 pi, and so on. Let's see what is the period. So this part of the curve from here to here repeats itself, right? Same thing here and here. So the period for sine 2 theta is actually from here to here, which is pi radians. Unlike sine theta, sine 2 theta has a period of 2 pi pi radians, sorry, right? So it's half of that. Sine 2 theta is half of that. So if you plot the same thing for sine 4 theta, let's plot for sine 4 theta, the period for sine 4 theta. Sine 4 theta would be a similar plot, except that the angles would change. So if you plot sine 2 theta, it will be much faster. Yes, and then something like that. So if you plot the angles here, this would be 0, this is pi by 4, this is pi by 2, which is this part of the curve repeats from here to here, and this is pi by 2, right? For sine 4 theta, the period is pi by 2. So if you see the pattern, for sine theta it's 2 pi, for sine 2 theta is pi, sine 4 theta is pi by 2. So it's going here from here to here half, and then one more, or 1/4. So it's something like 2 pi over 2 for sine 2 theta, and 2 pi over 4 for sine 4 theta. So we can generalize and say that for sine n theta, let's take a different color. So for sine n theta, the period will be 2 pi over n. So for sine 5 theta, the period should be 2 pi by 5. And similarly, if you take cos theta, so the plot of cos theta is something like this. This is cos theta. So this will be minus pi by 2. This will be plus pi by 2. This is 3 pi by 2, and so on. Now what is the period for cos theta? Let's plot cos theta. Cos theta would be something like this. It would start, say, same point, and then goes up, and then passes through the origin, goes down, passes through pi by 2, goes up, passes through here, goes down, something like this. So this is minus pi by 2, this is 0, this is pi by 2. So the period for cos theta is from here to here, and the distance from here to here is pi. So the period for cos 2 theta is pi. And similarly for cos 4 theta, it's pi by 2. So it's the same pattern here. So for cos n theta, let's say, so the period for cos n theta would be 2 pi over n. Let's see for tan theta. So we know that the graph for tan theta looks something like this. It goes from plus infinity all the way to minus infinity, between minus pi by 2 to plus pi by 2, and then pi by 2 to 3 pi by 2, and so on. So the period for tan theta is pi from here to here. Let's see what is the period for tan 2 theta. So for tan 2 theta, if you plot it, it will look something like this. It starts from infinity at pi by 4, it goes to origin, and then kind of saturates at minus pi by 4. So this would be, so if you draw the asymptote here, this is pi by 4, and this is, if you draw here, this is minus pi by 4. Similarly, it starts from 3 pi by 4 here, and then it goes through 90. At 90 degrees is 180. 2 times 190 is 180. So that is pi is 0. So here it's 0. So if you draw one more line here, this would be 3 pi by 4, and similarly it would start at 5 pi by 4, then goes through pi, and then saturates at 3 pi by 4. So this would be 3 pi by 4. Oh, sorry, 5 pi by 4. Actually, that's not the asymptote. The asymptote would be something closer to here for this. So this would be 5 pi by 4. So the period for tan theta was from here or here to here, which is minus pi by 2 to plus pi by 2. And the period for tan 2 theta, as we just saw, was from here to here, which is minus pi by 4 to plus pi by 4, and the interval is pi by 2, right? So the period for tan 2 theta is pi by 2. And similarly, if you find the period for tan 4 theta, that would be pi by 4. This would be even closer. It would start from pi by 8, goes here, and then goes to minus pi by 8. So the period would be minus pi by 2 plus pi by 8 is pi by 4. So in the same pattern, the period for tan n theta would be pi over n, meaning the period for tan 6 theta is pi by 6, and so on. So now let's generalize the periods for all the trig functions with multiple thetas. So here is a generalized formula for finding the period of multiples of angles on the trig functions. So the period for sine n theta, where n is a number, a real number, it's 2 pi over n, and cos n theta is 2 pi over n, tan n theta is pi over n, cot n theta is pi over n, cosecant n theta is 2 pi over n, and secant n theta is 2 pi over n. So if you see, we just divided with the multiple of the angle here with all the original periods of the trig functions. So the period of, say, tan 8 theta would be pi over 8, and the period of cosecant 5x would be 2 pi over 5, and the period of cos 7 by 2 theta is equal to 2 pi over n, which is 2 pi over 7 by 2, which is 4 pi by 7.